Well, hello everyone, and welcome to another episode with your girl Audrey Codner from ACG Math Tutoring. Hopefully you guys are doing all right. Just had to get some stuff done before we were supposedly have rain for God knows how many days. So that's where I was. So if anything, what we're going to do today, we're going to work on roots and radicals. So we're going to look at different types of roots and different types of radicals. This sounds like a band. I need for someone to make that happen. So if anything, come on in, and especially if you are thinking about getting your ACCUPLACER done, if you're thinking about doing the ASVAB, or maybe you're taking a college algebra course, or maybe even pre-calculus course, this will actually be the live for you. Now, for people that are taking their GEDs, there are certain components that is going to be addressed that will be in the GED test. So, sit back, relax, and let's do some math. So as you guys come on in, go ahead and just tap away. We're going to try to get to our 1K. Again, I'm only going to be here for like roughly 1 hour. So this is going to be a quick in, quick out jobby. All right, so let me see if I can find where everyone is. And then we will get started. Okay. So we got 15, 16 people. We got 1 like. Why are we holding on to the likes? Hello, Kim. Hello, Arthur. Welcome on in. Okay, Chantel. Yes. Okay, just go ahead and keep tapping so we can get ourselves moving and grooving. All right. So while you guys are doing that, I'll kind of have you guys zoom in just a bit of looking at what we're staring at. We are so used to square roots and squares, but there are so many other roots out there. There's the cube root, which I know some of us, if you're in Algebra 2, you've seen. Okay, Toya, how are you? Lisa, how are you doing? And it seems like once we get past Algebra 2, that's when we start seeing introductions of other types of roots, okay? So if you're one of those advanced kiddos that is already like, I'm already past, I'm on pre-calculus, and you're probably going to see a few other roots. So if you're a parent watching this and you know your kid is in that thing, bring them on over. If you know someone that is taking the ASVAB and they just need some of the advanced math, because the higher you go, the more math you're going to see, bring them on over. Okay. All right, awesome. Yep, so we're just basically looking at, and if you're like, okay, well, what roots and what radicals? Like, especially when you're doing with rational expressions and you have a fraction, okay, in as your degree. Degree is what is your exponent. So like if you're starting to see fractions like 4/3, okay, or 5/9, any of those things, this is definitely the live that you want to pay attention to, okay, because sometimes people are like, what do I do? Like, but you're going to see a lot of the components that's in Algebra 1 that's going to show up here that you're going to be like, oh, that's not too hard. That's not too bad. All right, go ahead, keep on tapping. I'll start up when we get to like 1K. Okay, and there's 92 of us here. So, hey, we should be able to hit that real quick. I lied, 93. Almost there. Beautiful thing. And we have over 100 people in here. Awesome. All right, so when we're looking at, and I always want to say there is a few properties that we need to go into. So when we have our nth root, this n is called the index. It tells you what type of root you're going to have or what type of radical this is going to be. So if you're having your radicand and it's being multiplied by that same expression, your answer is going to be A. So let me show you through example. So if I had, let me unzoom a lot. Okay, if I had, say, the fourth root, and you're like, what? That exists? Yes, it does. And if you have the fourth root of 21, and we're saying that this is actually being raised to the fourth power, these are inverses of each other. Okay, these are going to be inverses of each other. Now, here's the difference between an odd index and an even index. When it's an even index, you always take the absolute value of that number because your answer can't be a negative. So let me say, remember we had that whole thing with you can't have a negative underneath a square root? Because when you have a negative underneath a square root, that's when you're going to deal with those complex numbers, the i's. And we were talking about that a little bit last night. Okay? So anytime you have a negative number underneath the square root, this is going to give us complex numbers. But here's the thing. When you have an odd root, like a cube root, right? You can have a negative underneath there because if you think about it, a negative times a negative will give me a negative. Okay, negative times negative gives me a positive, and then the positive times the negative will give me a negative. So everything seems to work out well when it's an odd number. But if we have an even root, you have to take the absolute value of your answer. I know that the fourth root and the fourth are going to cancel out and give me the 21, but I have to make sure I take the absolute value when it is an even root. So that will give us our answer of 21. Because if I gave you, let's say, the sixth root of -4, okay, and that's being raised to the sixth power. Right away, I know that the sixth power and the sixth root, they're inverses of each other. Yes, this actually exists, okay? So I'm not just, she's just making some numbers up. No. This actually exists, okay? So when these two cancel out, we would say, oh, that gives me a -4. But then I can't have a negative if I try to do it in the opposite direction. So when it is an even root, we always have to take the absolute value of our answer. So our answer is going to be 4. Okay? So when it's an even root, after they cancel out, make sure you take the absolute value of it. Boom, that's your answer. Okay? But when it's an odd root, let's see with the green. But when it's an odd root, so let's say the cube root of, I don't know, -2. And let me say that degree is going to be underneath the radical. Doesn't matter if it's underneath the radical or if it's outside of a parenthesis. The cube and the cube root are inverses of each other. But since this is an odd root, I can go ahead and get a -2. Because when you're dealing with odd numbers, in this case, I can have like 3 -2s for some second. Because when you're dealing with odd numbers, in this case, I can have like 3 -2s for some second. Fluctuate as much as an even root. Okay. What just happened? I don't know. For some reason, I just got booted out of my own live. That's weird. Okay. All right. So now, going into all of this. So when we have, let's say, 8 raised to, let's say, the 2/3. Okay, so now we're looking at basically converting 8 to the 2/3 into a radical. Now, this is the whole process that a lot of people need to understand. When you see a fraction as an exponent, you always have to go with this process. It's your degree over your root. So, the easiest way for me to remind myself, if I said that it's like 7, well, actually, let me do the real heat around here. So right now, it's 96 degrees Fahrenheit here in lovely Baltimore. And I know if I said 96 degrees, my degree symbol is in the same spot as an exponent, okay? So when you think of degrees, the heat rises. So degree, as I like to call it, the heat will be on top because heat rises. Now, roots, I think of a tree. Because when you think of a tree, where are their roots? Underground. So it's going to be below the factor. So I always like to say heat tree. I don't know why. It just works with me and it sticks. So if anything, your degree is going to be the numerator. Your root is going to be the denominator. So it's going to tell you what type of root you're dealing with and to what degree. So when I have 8 raised to the 2/3, they're saying that 2, that's going to be my degree. And the 3 is going to be the index for the root. So if I want to translate it, I'm going to have my radical. And it's not going to be a square root. It's going to be a cube root. So it's a cube root of 8 raised to the 2nd power. Some people like to put their degree on the outside. Some people like to put it underneath. I like to put it on the outside because if I need to break this down, I need to think what number multiplied by itself 3 times will equal 8. Yes, so it's definitely the cube root of 8 to the 2nd power. There you go. Good. Casey is saying 2 because 2 times 2 gives me 4 and 4 times 2 gives me 8. So that means I can break down that cube root of 8 to get a whole number of 2. And now I go to the exponent. 2 to the 2nd power, my answer is going to be 4. Okay. What we also did, besides the conversion, was an advanced version of please excuse my dear Aunt Sally. We did what was inside the parenthesis. That's where we got the 2 from. We did the exponent. That's where the 2 squared comes in to get our answer. Okay, so you see a lot of those foundational pieces keeps popping up as you advance further and further into mathematics. So that's why it's so vital. Okay, a lot of people are like, I've never done this in my life and all this stuff. Yeah. But here's the thing. Just because it's not in this format doesn't mean that it's not actively being used. You guys use parabolas all the time. You guys look at circles all the time. You guys make decisions. So that is the either inductive or deductive reasoning. Okay? A lot of that stuff is happening. So as we break down, we show it piece by piece. All right, let me take a look. Let's see what you guys are saying. Because for some reason I got booted out. Hey, Lynette. I need to chat with you. We haven't chatted in a minute. Okay. All right. Internet acting up. How do you take the root of a negative number? Tony, actually take a look. If you go here, okay, I talked about that last night. Okay, all of my lives are recorded and you can find it here. All you have to do is just type in this, or you can type in this. And if you can, do this, do this, do this, definitely do that, and do this. Okay? So we talked about that exactly last night. All right. The internet doesn't want us to learn. I don't know. It's crazy. Okay, we got that. All right. Different answers. What? All right, we're gonna take care of this. All right. All right. Tyson, all right, got you. So you're good. We're not talking about that person. All right. So, now, if we have, let's try this. Because now I'm going to give you some other ones and you're like, wait, what can I do with that? So what happens if I flipped it? And if I said, I think I got a little bit of room over here. If I said, same process, same numbers, different situation. Okay. So we have negative 8 raised to the 3 halves. Okay, so negative 8 raised to the 3 halves. So if I'm dealing with my radical, I know my radicand is going to be the negative 8. But what type of index am I going to put here? Is it the 3 for cubic or is it 2 for square? What is it, Sean? I already blocked him, so you shouldn't be hearing anything from him. Shasan, yeah, already blocked him. Okay, so you're saying the 2 for the square. Okay, 2 for the square. Angela's saying 2. Okay, good, because that's going to be my root. Now here's the thing, you don't have to write the 2. Okay, anytime you see a square root, you should be thinking of square. So, but this is being raised to the 3rd power. That's my degree. So can we do this? Okay. Okay, can we do this? All right. Square root of negative 8. Can I do that? Okay, one jump. Do we have any problems or what's going on? The number won't be pretty. Right, the number won't be pretty at all. Okay, we'll be having imaginary numbers. There we go. That is okay. Actually, it's not, but, my whole thing is, if you guys want to be political, you can take it off and you guys can have a conversation. Me personally, I do not like having that on my platform. Okay? All right, I really just want to do with the math, okay? All right. So now, anytime we have a square root and there's a negative underneath, this is what we got to do, what we did last night. we're going to have to break down what's inside the parenthesis first before we tackle onto that degree of 3. So anytime it's a square root, we should be thinking about complex numbers. So if we have the square root, we got to pull out the I. Okay, so that means that's going to be the square root of -1 and the 8. Square root of -1 is my symbol of I. But square root of 8, we can actually break that down. We could break that down into 2 radicals being a perfect prime combination. So you got your 4 and you have your 2. All right. Hey, Evelyn, thank you for the gift. Appreciate it. Okay, there we go. Okay, not root of 2. So, no, root of 2 is still in there. Because the square root of 4, that will give me 2. Now, we have this I, we have this 2, and it's being multiplied. So that gives us our 2I. Now, the square root of 2, that's prime. If I can't break it down, I'm going to bring it down. Okay, so if I can't break it down, I'm going to bring it down. So right now, I have 2I square root of 2. Okay, cool. I love it. All right. So now, what's missing? Okay, and I can tell you for sure, this will definitely be one of the answer choices. Because we forgot to do something. What did we forget? Yes, the cube. Remember, okay, we basically broke down and we have it surrounded by a cube. So we need to surround this by cube. Okay. So now we need to cube everything that's inside. Now, I notice when I get to this part, I'm always looking at my answer choices to see if I have to do that. Okay, so that means I would have to cube the 2. Then I would have to cube the I. Then I would have to cube the square root of 2. Now, I'm going to be truthful. It's going to be messy. It's going to be messy. And the reason why is because this is a square root and I can't break it down with a cube. So it's just going to be a parenthesis square root of 2 cubed raised to the 3rd power. But then this will be 8. This will be an I cubed. So we can either leave our answer like that, or it's going to look like 8I cubed, and then parenthesis square root of 2 cubed. So one of these 2 will be your answers. This one is just, distributed out a little bit more. Exactly. So that's why you can do the foiling, you can do the distribution, you can do all that. But here's my thing. For the standardized tests, for GED, ASVAB, ACCUPLACER, all that, they're not going to have you break this into 3 different parentheses. First of all, there's no plus signs. Now, if there was a plus sign in between, yes, we're foiling. It's going to be ugly. But since this is all multiplication going on inside that parenthesis, that's why I can simply distribute that 3 to everything inside. Okay? All right? So we don't have to do all that. And plus, most of those exams are not, and I repeat, are not going to make you do anything super extravagant like that. Because remember, it's a timed test, and they don't want you to spend like 15 minutes on one problem. Okay? All right. All right. Awesome. I'm glad. I'm glad you're saying it's your weakest subject, but I'm glad that you're here, that you're still following. Thank you. All right. Okay. So let's get with another one. Yeah, so I'm just really trying to hit on just those fun little exponents. So I'm gonna slide over. If you guys tap a little what is the topic called? Roots and Radicals. Be an awesome name for a band. Matt, make it happen. Get the guys together. I will not be lead singer though. You can do that. Okay. All right. I really think it's a cool name for a band. Watch. One day someone's going to be like, welcome to double, or like R squared, or RR, or something like that. Hello, Cleveland. All right. So if we do something like, let's see if we can reverse it. So what would this? What would that be as an exponent? What would that be as an exponent? Hey, Van, how are you? Oh, that's fabulous. Thank you so much. Appreciate it. Yes. So we got x raised to the second power. We have 6 divided by 3. Okay. Anyone else? Okay, we have x raised to the 6/3. Okay, any other guesses? All right. Okay, Yosef, how are you? I haven't seen you in a minute. Okay, Pog, 6 1/3. Okay, so remember, it's your degree over your root. The degree is 6, your root is 3. Now, this can be simplified. Okay, simplified to our x squared. Okay. So I know we get so caught up in the process, which is great, which is awesome. But remember, we always can simplify. All right. Nice. Perfect. All right. So if I had, let's try this. Okay, we can do this. So I just want you to know, do not be afraid of dealing with roots that's not normally squared or cubes. You're kind of using the same philosophy. Okay, what would that translate to be? So we have the 4th root of x cubed y. Okay. Oh, thanks for following and sharing the lives. Appreciate it. Jason Reborn. I like that. All right. Okay, so Matt's saying x raised to the 3/4 and y raised to the 1/4. Hey, 6'5", how are you? It's been a minute. Everyone's coming out of the woodwork today. So Casey's saying x raised to the 3/4, y to the 1/4. Make it into a rational number. Okay, stays the same. Let's see. Okay. So we have our base. We have our x. We have our y. So remember, it's degree over root. So the degree for the x, we have a 3, and the root is what type of root it is. It's the 4th root. So the 4 will go down here. Now for the y's, if we don't see anything in the exponent, we assume that it's a 1. And then over my root, which is 4. Now, when it comes to multiplying these two, they don't have the same bases. So I can't combine them, okay? So if they do have the same bases, which I'm going to show you next, you can add your exponents. So I think some people get confused when it comes down to operations using the exponents. When you multiply, you add your exponents. Think of it this way. When you multiply, you're making numbers bigger. When you're adding, you're making numbers bigger, okay? When you're dividing, you're making numbers smaller. When you're subtracting, you're making numbers smaller. So you want growth with growth, shrink with shrink, okay? Multiplying, you're going to add the exponents. Divide, you're going to subtract the exponents, okay? So this loveliness is our answer. Oh, well, hello and welcome. This is roots and radicals. So we're dealing with other roots and other radicals other than squares and cubes, right? Awesome. Going into geometry. All right. Yeah, so you'll see this when you get into Algebra 2. But for right now, why not? Sit back, relax, take a load off. All right, so let's do some operations, shall we? So if I have 3 1/4 times 3 3/4, what's my answer? It's called the Ultimate Math Notebook. Yep, the Ultimate Math Notebook. I'm making some improvements, and that should be released by the end of this month, so next week. So if you want to hold off on, you can. All right, so I'm seeing 3, I'm seeing 4, I'm seeing 3 raised to the 3/4, I'm seeing 9s. Oops, sorry, getting a little crazy. I'm seeing 9s, I'm seeing 3 raised to the 3/16. Okay, no, wait, all right. Joe is telling me 9. Okay. Got a person with a heart that's saying it's 3, y'all. Okay, he's just saying 3. Oops, you meant 9 to the 3/4. Okay, is placed under the number. What's being the degree squared? Do you have any books on? I do. I just told you. Okay, so you're saying, yeah, it's 9. All right, let's take a look. Here's the thing, guys. You have 2 of the same bases. You are multiplying. You're not multiplying the bases. Remember, when you have your bases, they're exactly the same. You can keep that base, and then you're going to add your exponents. Okay, so if I said a is raised to the 3rd power times a to the 5th power, I'm going to get a to the 8th power. Because if I have 3 A's here, I have 5 A's here, that means I have a total of 8 A's. The same thing is happening over here. The only difference is my exponents are fractions, are rational numbers. So I have the same base, we're keeping the 3. Then I'm adding the exponents, 1/4 plus 3/4. They have a common denominator, so that means I can just go right into adding the numerators. So 4/4 gives me 3 raised to the 1st power, which is 3. So we're not doing anything with the bases, okay? These are not 3, how should I put it? It's not 3x times 3x. Okay, if it was 3x times 3x, yes, you will get your 9x squared. That's what it's not. New. Okay, these are bases, these are exponents. So if you have the same base, you add your exponents if you're multiplying. Okay, hello Swan, how are you? Okay, now with division, if you have the same bases, you're going to subtract your exponents. Is that Bijou? So what do I do with the 4 over 4? Divide it. 4 divided by 4 gives me 1. So anything to the first raised to the first power is itself. That's where the 3 comes from. Yes, bases with exponents. So if the bases are different, okay, you won't be able to do that. They have to be the same. All right. Yeah. Okay. There we go. So again, the bases are different, can't do it. They could just get next to each other. Can't combine them. Yeah. All right. Yep, it cannot be simplified. Third time saying it. It's okay, guys. I know. All right. I love everyone's like, can we see an example? I have a whole list, guys. Keep your panties on. Like you're like running. Oh my God, when am I gonna do this? Relax. This is why you're so stressed right now. This is why. Okay? Calm down. It'll be all right. Sheesh. Oh my God. What happens if she doesn't? Then all of a sudden it just disappears and then she just leaves the face of the earth. Like, dude, if I'm not on TikTok, I'm gonna be here. This is where I'll be. Okay? Trust me. Unless the good Lord is ready to take me, you'll be able to find me. Jeez. All right. So we have 2 1/5 divided by 2 6/5. Just trying to keep it simple so we can understand this. All right. We have the same bases. So we're going to keep that base of 2. But when we're dividing, we're going to subtract the exponents. So you have the 1/5 minus the 6/5. Okay. So they have the same denominator. So that's going to be easy for us to finagle. So that means I have my 2. Then we have 1 minus 6. 1 minus 6 gives me what? There we go. Good. Thank you, Kaya. So we got our -5. -5 over 5. Okay, BB doll. Good. Got that. Is -1. That's it. Carrie. Welcome back, Carrie. -5. Baby doll, same with you. Or BB doll, same with you with the welcome back. All right? No. It's not 2. Be careful. So, you did everything perfect up to that point. So, you had your 2. You told me that -5 divided by 5 gives me a -1. I have a negative exponent. Yes. Thank you, babes. Okay. All right. So we have a -1. Okay. Anytime you have a negative exponent, you got to flip it. So that means this original is assumed to be over 1. It doesn't change the value of that 2 raised to the negative 1 right now. We're just making it into a fraction so we can get that flip. So that means the 1's going to be in the numerator. And now you got 2 raised to the positive 1. By you dropping it down into the denominator, that's having this negative negate itself. So a negative times a negative will give me my positive. So now 2 to the first power, that's simply 2. So we got 1/2. For those that said 1/2, awesome job. Okay, we got our 1/2. Okay, nice. Yep. So 6/5, it will be 2 raised to the negative 1. Okay, I see what you're saying. I see what you're doing. My fault. Ignore me for a second. Ignore me. Okay? Exactly. G306141. Okay? That's exactly what it is. It's exponential rules. So just because we see it in this light, because we have rational numbers as exponents, you don't forget the rules. That's all it is. It's the basic stuff that's showing itself in more advanced placements. That's all. That's why when people say, I can't do math, I'm like, you know how to multiply? Yeah, all right. Do you know how to break down a fraction? Yeah, all right. Do you know how to add, subtract, multiply, and divide? Yeah. With variables? Yeah, pretty much. 1-step, 2-step, 3-step, multi-step equations? Yeah. Dude, you know how to do math. You got it. You just need especially if you know the multiplication table, dude, that's more than half the problem. Boom. Done. All right? So, give yourself some credit. All right, not a problem. Not a problem. When do you go back to school? Or did you already, not to put salt in that wound, like, you still got some time. All right, speaking of time. All right, let's see if we can get some more taps here. 240. Don't leave. Oh, I'm not going to leave yet. You're studying for a GRE? Okay. Yes. Yeah, they always throw that in there. This summer? Yeah. Well, I think you probably have, a couple more weeks left? 2 or 3 more weeks left? I know. Before we know it. Before we know it. All right. Let's try this one on for size. Because you guys can tap and I can teach at the same time. You know, that's how it works. Yeah, a lot of people generally second guess themselves. But here's my thing. It comes with practice. I'm sorry, it comes with practice. And you can't rely on other people to say, if you hired me for a tutor, just because you hired me for a tutor doesn't necessarily mean that you automatically going to get an A. Because you still have to put everything into action. Okay, you're going to have to do the memorization. You're going to have to do the practice and put it into your brain. I'm here to guide you, to train you, and just say, hey, yes, no, don't do that. Or why do that? Because you're making things so much harder for yourself. Just do this because you can explain it by doing this. That's what I'm supposed to be doing for. Okay, but you guys put it into action of trying to understand it. Okay, August 4th. Wow. Yeah, that's right. Yeah, South Carolina, you guys do go back early. I have a couple of kids there. Well, not in that, I don't think they're in Lexington. I have to double check. But I do have some kids, South Carolina, that's starting up. Alaska is starting up next week as well. I mean, not next week, but the following week. The teachers go back next week, but the kids go back the following week. All right. Yes. Look at this. I love it. Okay, so now when you have your 3/2 being multiplied to your 1/3, okay, when you have a power being raised by a power, you multiply the exponents. So you keep that base of C. Now you're going to have your 3/2 times your 1/3. Okay, for those that don't really see it, hopefully you do see that right here, the numerator of 3 and the denominator of 3. 3 divided by 3 will give me 1, so they can kind of cancel out. So that's going to leave me with C raised to the 1/2. So that's what it looks like, okay, as your exponent. What would it look like as a root? What would it look like as a root? You go back August 29th? Jeez. 28th? Good God. Does it seem like you guys are going back earlier and earlier and earlier? Okay. Hey, Lin Lin. I love that. Okay, the root of C. Good, Joe. Okay. Good. The square root. Good. Because our root is 2, so we don't have to put the 2. Now, for those love to do calculations on your iPhones, if you're looking for the square root, they actually have the 2 as the index. I didn't make it up. I'm not here, but that's what we do. So then you bring your C underneath, and then since it's raised to the first power, I don't have to put that there. So either one of these will work as your final answer. Okay. Nicely done, guys. Nicely done. All right. So let me see if I can challenge a little bit. Let's see what will happen. There was anarchy on TikTok today. All of a sudden, they're like, I don't know what's going on. It all started with a math problem divvied out by ACG Math Tutoring. And then you'll see a picture of me smiling with my thumbs up. You'll understand when you see what I'm doing. She's like, wait, what? How are we feeling? Yeah, you don't need the 2, baby doll, because the lowest root you can have is a square root. There's no such thing as a 1 root, so you don't have to put the 2. It's assumed to be there. Okay. People are probably saying, we were friends until this. Until this very spot. We were good. Okay. Scary. Don't be scared. Don't be scared. Don't look at it as one big problem. Take it piece by piece. Shasan is saying 5 root of y raised to the 4/3. Matt is saying raise the 5th root to the 5th power. And the radical and exponent cancels out. Then you get y to the 3/4. I would agree with that if it was an equation. It's not an equation. It's algebra 2, so I'll need to go into algebra 2. It'll be nice to know. Like, you don't need this in the first month of school. Usually this is happening like around 3rd quarter, I think. Okay, a square root and a square root. That's diabolical. And look at Pog. It's saying y raised to the 4/15. This type of expression in your life. Okay. first step is y raised to the 4/3. Okay, y raised to the 6/5. Okay, a couple people got the answer, but I love the effort. Okay, a couple people got the answer, but I love the effort. I'm loving that. I'm so loving that. Oops. See, I'm not doing anything. I don't know why it's like flipping out. And when you see it, you're going to be like, oh my goodness. Oh, you could put roots within roots. You can't just have a negative underneath it. Okay, ready? Let's work on the inside out. So right now, let's ignore this 5th root. So we have the cube root of 4. If I can change that to an exponent, what would it look like? Y raised to the what power? Y raised to the what power? Right, you're correct. Okay, when you have a negative, especially for even roots, yes. All right, good. Matt saying 4/3, Carrie saying 4/3. Okay, user, all of that, saying 4/3. Good. Remember, it is your degree over your root. Okay, degree, heat, your root tree. Now, putting a little parenthesis around that. How would I talk about the 5th root? How would I put that as an exponent? Okay, how would I put this as an exponent? Just the 5th root. Remember, heat tree. 1/5. User, Casey, 1/5. Okay. Okay. Not really 0/5. There is going to be something here because there's still something underneath. Not 2. But it's lovely to see you again. Perseus! All right, there we go. 1/5. Yes. So our degree will be 1. Our root is to the 5th. So now we have a power being raised to a power. What do we do with these two numbers? They have the same base, but they have a power being raised to a power. What do we do? There we go. We multiply. We multiply. Anytime you have an exponent, a parenthesis, and an exponent, you're always going to multiply. So we have our y. Then we have our 4/3 times our 1/5. So we don't have anything to cross simplify. So our answer will be y raised to the 4/15. Aw. I remember those days with my dad. I'm glad you're here. Okay. So it's really taking an extra spin, just a little extra spin on the properties of exponents. The only difference is instead of whole numbers, we're dealing with fractions. And I know you don't like fractions, but These are some of the things we deal with, okay? So all you have to do is break down what's underneath. Always work from the inside out. Turn that into our expression. Then have what's wrapped around, turn that into an expression, and then you multiply your exponents. All right? Okay. So, real quick again, give me some time. It's going to take me probably later on like this evening. If you want to get the replays of this, please go here. Okay, type in either this or this. And if you can, go ahead and hit subscribe, like, comment. If you can share it, if you know somebody that is about to go into high school or they're thinking about going back to school and they're thinking about taking college algebra and they're like, yeah, I'm going to be fine. I'm like, dude, you're taking a 12-week class and you haven't been in school since you were a fetus. Go see Audrey. Hire her, okay? My hours are going to change, but of course, after I had a couple people today, it might change again. So I'm going to wait until I'm officially ready for my fall season, because next week, some of my hours are going to start changing because my kiddos are starting to come back. Now, if you need a tutor, maybe you're a high school student and you have to do your summer reading packet and you haven't touched it and it's starting to get up to you. We could probably get it done in like 2 sessions. So if you do need assistance with that, please go ahead and reach out to me. Just have to hit a DM and we'll just take it from there. If you want a course for like GED, ASVAB, ACCUPLACER, TEAS, or maybe even just for foundational algebra and you just need some guidance with it, I got like 107 videos. There's some practice sheets, a couple quizzes on there. And then these are the prices for my courses. But for the $197, you also get 2 30-minute tutoring sessions with me. So I don't know. That's something like that. So if that's something that interests you, just go here. And then you can see the spot with the courses and also with tutoring. Now, I also have my books. If you like my books, like say this notebook that I have right now, you can go to the A, because I can't say the actual name. You can go to the A, you can purchase it there, but I only get 50 cents per book. All right, so this kind of like walks through with the formulas. You can use the formula and then also what are the steps. And then it gives you room to actually work out the problems. And it's usually like 100 pages. But in addition to that, you're also going to get a resource page, which is at the very back. If you're not strong with your multiplication, we have our factor sheet. Then we have the rules of integers. We have the order of operations. We have like for circles, volume, surface area. We have the unit circle. And then we also have Pythagorean theorem and SOHCAHTOA and some other trig identities. So my new one, which is going to be released, my second edition, is one's going to be for just Algebra 1, Pre-Algebra and Algebra 1. So it's dealing with the fractions, it's dealing with percents, place values, all that mixed in with some of the Algebra 1 components that I have on here, especially that factor sheet. All of my books have the factor sheet. Okay, this is so beneficial from like 1 to 200. Most people I've seen selling it is like from 1 to 100. And then I'm going to have one for Algebra 2 and pre-calculus. So a lot of the formulas there. And I have to slow down so I can do geometry, but that's going to take a minute because of all the lovely proofs that goes into it. So just be on the lookout for that. I'll let you know when the big A releases it. But if you want my actual notes, I actually have a book called Audrey's Notes. It's a little play on Cliff Notes, where if you have certain topics that you want me to do and you want to get a copy of my actual notes, you can do that. And what happens is there's a QR code at the very bottom. It takes you directly to the live that is in reference to this topic. Okay, so this one was dividing by 1 and 2 digit numbers. So all you have to do is just scan that and it'll take you directly to the live. Okay, so it all fluctuates. 1 minute we're talking about factoring, next minute we're talking about system of equations, then we're doing a little bit with matrices, and I have books 1 through 4 already out, and we are currently working on book 5, as well as I'm working on developing a left-handed edition because you gotta love the lefties, and I'm actually dedicating that to my father, who has passed about 9 years in August. So the month of August, if I'm like ready to feel like I'm about to break down, it's because I'm about to break down. I'm working on it. All right, and then last but not least, this weekend. Okay, she's right there. Okay, so I got to get going. So if anything, if you're interested in a mock practice test, if you guys have final exams next week and you want to go over some stuff, make sure you reach out to me. I do have some time tomorrow at 10 a.m. and also Sunday at 7 p.m. Okay, so that's what we're going to be doing. And again, if you need me, you go here and there. If you have any questions, just go ahead and send me a message. I'm going to definitely take a look at my messages in the next 3 hours. All right. Okay, everyone, have an amazing day. I will see you tomorrow evening at 7 p.m. for more fun and all great things aside. All right. Love you all. Take care. Keep being amazing. Bye now.